All right, so in this problem, we want to find possible inflection points and then describe the concavity of the function. So the idea is to find the second derivative, figure out where the second derivative is undefined or where it's equal to 0, and then study the intervals around those values. So let's first find the first derivative. So f prime of x, we're going to use product rule. We have one function times another. So the derivative of x is just 1. Keep the second function as is, so times 9 minus x to the 1/2. Plus x, keep the second function as is. So using power rule, times 1/2, the 9 minus x, 1/2 minus 1, the negative 1/2, times the derivative of the inside, which will be the derivative of 9 minus x, which is negative. Now let's clean this up a little bit. So then this will be 9 minus x to the 1/2 plus, or plus a minus, so minus x times 9 minus x to the negative 1/2 all over 2. All right, now let's find the second derivative. So first take the derivative of this. That will just be again power rule, so that'll be 1/2 times 9 minus x to the negative 1/2. Or yeah, to the negative 1/2 times the derivative of the inside times the derivative of 9 minus x, which is going to be negative 1. And this will be, I actually probably should have read it differently. This is again product rule. It's like a minus 1/2 x times that. So let's do minus, let's put that in brackets. So minus the derivative of 1/2 x. This will just be 1/2. Keep the second derivative as it, or keep the second group as is. So times 9 minus x to the negative 1/2 plus keep the x over 2 as is. So plus a 1/2 x times the derivative of 9 minus x to the negative 1/2. So using power rule, be negative 1/2 times 9 minus x minus 1 to the negative 1/2. It's a negative 3/2 times the derivative of 9 minus x would be times the negative 1. Now we just got to simplify as best as we can. So let's try not to get this so messy. So let's see, we both have, these both have a 9 minus x to the negative 1/2. So we can combine these. So it's a 1/2 x or negative 1/2 x or negative 1/2 times a 9 minus x to the 1/2. So let's go. So negative 1/2 minus a 1/2. So then I'll be just a negative 1 times a 9 minus x to the negative 1/2. Those two combine there. So minus minus, let's make this a minus, and the minus, plus, and the minus, so it makes it a minus again. So minus a 1/2 x times a 1/2, so minus a 1/4 x times a 9 minus x to the negative 3/2. Now we want to combine these terms because that'll make it a lot easier to solve for the zeros and undefined values of this equation. So let's make them both have a common denominator. So let's rewrite this as a negative 1 over 9 minus x to the 1/2 minus a 1 x over 4 times a 9 minus x to the 3/2. So what I'm missing here is I need that 4, and then I need 9 minus x to the 1 here. So what I'm going to do, I'm going to write small here so I can save some space. I'm going to multiply the top by 4 times 9 minus x to the 1. And same thing with the bottom. 4 times the 9 minus x. Because then you'll have the same denominator all across. You'll have this equal to, in the denominator, you'll have a 4 times the 9 minus x to the 3 halves. And this will just be a negative 9, or sorry, negative 4 times 9, so negative 36. Negative 36 plus x minus that 1x. Or plus 4x is what I use. Let me put this in color. So minus 36 plus 4x. Minus 36 plus 4x. Minus that 1x. And then also just be negative 36 plus 3x. All over 4 times the 9 minus x to the 3 halves. So this will be my equation for the second derivative. So I have to find where the second derivative of x equals 0, or where the second derivative of x is undefined. So to figure out where it's 0, I just set the top equal to 0. So I just have 0 equal to negative 36 plus 3x. So that means x will be 12. So that'll be one value I'm gonna study. So x equals 12. And then it's undefined when 9 minus x equals 0. Because that means we're going to divide by 0. We don't want that. So that means x will be 9. Now, here's the thing. If we go back to the original function, you want to always study the domain, because if these values aren't even in the domain, or if they're at the very border, then you don't have to worry about dividing your interval more into a region. So let's look what we got here to show you what I mean. So the domain, since we're taking the square roots, we need it so that 9 minus x has to be at least 0. So the domain only consists of x values that satisfy this, which means that the domain has to be that 9 is greater than or equal to x, or that just means the domain will be from negative infinity to 9. We include 9 because the largest number you can put in here is 9. If you put in 10, you're going to get the square root of a negative number, and that's not going to be that's going to be a non-real solution. We're only talking about real numbers for now. So if you look here, this is at the border. This is right at 9. So like it's still in the domain, but you know, if we're going to make an interval, that's what we're going to do next. Our interval has to only start at 9 anyways, or end at 9 anyways. And then, so then that'll just be like negative infinity to 9. It works out there. But this is outside of the domain. This is 12. Like if I want to, in other words, if I like, you know, 9 to 12, or 9, if I want to like 9 to 12 without thinking, that wouldn't matter because I can't put anything bigger than 9 in here. So you don't have to worry about studying this. So make sure you check the domain, because this is going to save you a lot of work, because now we just have to check values in here. So we want to find what the second derivative is. So we'll just pick any value in here. So let's find the second derivative of like 0. That's always easy. Second derivative of 0, we just plug 0 into here. We get negative 36 plus 3 times 0 over 4 times 9 minus 0, which is 9. and you'll get negative 36 over, well, to the 3 halves. We'll get a negative 36 over a positive number. We're gonna negative over positive. Again, you don't even have to go as far to find the exact value. We just know this is negative. This is a negative number because you have a negative on top and a positive on the bottom. So if it's negative, then we know that the graph of f of x is going to be concave down. So then we can just say the graph of f of x is concave down on its domain. Let's say f of x is concave down on negative infinity to 9. And that means if it's concave down, it doesn't ever change, its concavity. So that means there are no inflection points. And, and that's it. That's all there is to it.